Hi, this is my second video. Today I'm going to be talking about an interesting concept. For those of you who are taking or have taken multivariable calculus, you know that it basically introduces the 3D graph. Um, so there's something that the professors, at least my professor, didn't really go over, and um, the reason why is it's probably um, the theory of it is not that complicated, but the practice is, could be pretty tedious. So I want to talk about parametric planes, how to or parametric surfaces rather, how to write the equation of a surface in parametric form. Okay, so let's start off simple. So we need to be in R3 to do this. So um, okay, so x, y, and z are all outputs. They're dependent variables, all three of them. So um, so yeah, okay. So you can see right here, they're all going to equal something. Now let's just write constants down. Let's make x equal to h. Let's make y equal to k. Let's make z equal to m. These are just constants. So if you, sorry, yeah. So if you graph this equation, you're going to get a point, a space point, space dot. I'm not sure what they call it. Very elemental. Now, I'm sure these three dependent variables are all in terms of no variables. Um, so that's why you get a point. Now, I'm sure you covered what happens um, if they're all in terms of one variable. So x equals f of t, y equals g of t, and z equals h of t. Yeah, like, so if you look at the bottom, and this, as I'm sure you know, gets you a space curve. So some kind of curve that doesn't lie in a plane, it just travels through space. Now, I think you can sense a pattern. So the variables in terms, or x, y, and z in terms of no variables gets you a dot. X, y, and z in terms of one variable gets you a curve. So by logical extension, if we had two variables, two different parameters, we could get a plane. So it would be in the form of x equals f of s comma t, y equals g of s comma t, and z equals h of s comma t. Uh, so like this. Um, so this will get you some sort of surface. Uh, okay, so that wasn't too hard. the next thing I wanted to talk about is I kind of want to do an extension of space curves. So, well, we already discussed a space curve. Um, we talked. We just talked about a space curve in parametric form. Now, um, I want to talk about space curves in Cartesian form. So, so now we're no longer going to have all three variables x, y, and z. We're not going to have all three of them be dependent variables, outputs. Um, we're just going to have two of them, y and z, be outputs. Okay, so now once we've done that, um, once y equals something and z equals something, um, yeah, once we've got rid of the x as a dependent variable, these two, these, this, both of these are automatically in terms of x, regardless if you have an x in your equation or not. So there's no way you can get a dot with just y equals something and z is something. The lowest you can get is a space curve. Okay, so in terms of one variable, so in terms of zero variables is a dot. In terms of one variable is a space curve, and in terms of two variables is a surface. And that goes regardless of how many dependent variables you have. How many outputs or um, yeah, how many outputs you have. So a space curve in Cartesian form is just going to be y equals f of x and z equals g of x. So this will be some sort of space curve all along the x-axis. It can go anywhere in the y and z axis, but it's going to go along the x-axis always. Okay, now I want to talk to you about partial the partial parametric form of a surface. Okay, um, so when I said if we eliminate the dependent variables, if we reduce it to 2, then the lowest we can have is a space curve. But we can also have a surface. And what do we know about surfaces? Regardless of the number of dependent variables, a surface will always be in terms of two variables. So that means the partial parametric form of a surface is, again, we're treating the y and z as the dependent variables, the outputs. Y equals f of t comma x, and z equals g of t comma x. This is also gonna get you a plane. I keep calling them planes, a surface. This will also get you a surface. Okay, so, and obviously, if you reduce it to one variable, well, or one output, one dependent variable, then the lowest you can get is a plane, and that's something you always do every day, and so this is nothing new. Okay, I hope you enjoyed my video. See you soon.